All right, so in this video, I'm going to be talking about page 16 from the notes packet. This is where we are evaluating functions from graphs and from tables. So this is not an entirely new concept, more of just a different way of looking at something that we should already be pretty familiar with. So when I think about what is f of -1, well, that's saying when x is -1, what's the value of the function? You can see that it's 1, right? When x is -1, y is 1. What is f of 2? Well, when x is 2, what is y? And here we have a piecewise function. So what this is saying is that um, the function is not continuous at 2, but the value of the function is always the filled in circle. Right? The filled in circle is actually at 2. What is it equal to? It's equal to 3. And then one other thing that we can do with this, just like we did with function notation when we were doing it from equations, is with graphs, we can also kind of combine them in different ways. So f of 0, we know that's going to be 0 plus 3 times f of 1. You see that f of 1 is going to be 1, meaning that f of 0 plus 3 times f of 1 is just going to be 3. And we can also go backwards. We can think about for what values of x does f of x equal 1? Well, here's the line, right? Y equals 1 or f of x equals 1. What are the x values associated with where a function crosses that line? And you can see that it's x equals -1 and x equals 1. All right. I want to add one more thing here that I wish I'd put in the notes packet when I was first building it, but that is, no, I'll do that down here. Sorry. Because we can also do that from tables. So this table says, here's our x values, 0, 1, and 2. And then we have a function. So if we say, what is g of 0? We're going to go to the column that says 0 and the row for g of x. This means if you plug 0 into g of x, you're going to get 5 out. And then k of 2. So here's our function k of x, and you see if we plug 2 into k of x, we're going to get 1 as an output. Now k of 0 plus g of 2, so now we're looking at the opposite, right? Before we had g of 0 and k of 2. Now we're looking at k of 0, so here's our function, here's k of 0, right? Because 0, then we're looking at k of x, so that is 4, plus g of 2. Here is g of 2, because here's 2, and then g of 2 is 2. So the sum of those is going to be 6. Now we have 3 times g of 1, and g of 1 is right there. That's -3. Minus 2 times k of 2, and k of 2 is right there. K of 2 is 1. So that's going to be -9 minus 2, which is going to be -11. And here I want to add something that we can also do composition of functions with stuff like this. So I can also say, what is g of k of 2? Right? G of k of 2. And that's saying, if I take x as 2 and plug it into k of x, I'm going to get 1. So k of 2 is equal to 1. So that means g of k of 2 must be equal to g of 1, of the value of k of 2. And what is g of 1? Well, g of 1, that is -3. All right, use both the table and the graph above to find the value of the expression below. So we have f of -2 plus g of 0 times k of 2 plus f of 0 times g of 2 squared. So combining these two functions, let's take it piece by piece. So first of all, what is f of -2? Well, this is our function f over here. And when x is -2, we can see the value of the function is 4. Plus g of 0, well, g is down here. See that g of 0 is 5 times k of 2, which is right here, right? X is 2, and then we're looking at k of x. So it's going to be 1 plus f of 0, which again is up here, which is 0. And then we don't care what g of 2 squared is because it's multiplied by 0, so it's going to disappear anyway. If you wanted to find g of 2, though, g of 2 would be 2. And so we can see that the result here is 4 plus 5 equals 9. All right. So that's the end of page 6.